thanks for coming in, everyone. I'm assuming everyone that's here has been doing a bit of soil monitoring. I've seen a little bit of the feedback that's come through in the photos, so that's really good. I guess, yeah, you guys have been putting a few posts up on Facebook, which James and the crew have been monitoring. I don't use Facebook, so I haven't been in there, but I have seen all the feedback that is put together on the summary kind of file for me to look at. So yeah, I guess the first thing I'd like to sort of ask everyone is, how did you find the monitoring? Like those of you that did some serious monitoring, how did you find the process? Give us some thoughts about how it went or what you felt as you did it, or after you did it. Like, yeah, just give us a bit of general feedback. It's probably a good first step. Anyone want to throw in any thoughts?
I think James is just might be making it in, so but while he settles, yeah,
no worries.
great to hear from everyone. And yeah, I guess I didn't take the opportunity to introduce everyone that on Sarah Fee that's been chatting with quite a few of you on your posts. I'm the agroecologist with Soils for Life. So
thanks, Sarah. Yeah. Yeah, so any thoughts from anyone? Anyone want to kick it off by giving us their thoughts on how the monitoring went? Just chuck your hand up first. So yeah, Matthew Smith.
Yeah, look, we did it together and we thoroughly enjoyed it. We sort of felt like we went back to school. Sort of doing high school tests, and it was quite amazing. I guess like the one for me was the soil organisms from the top. Kind of look at it and you think, oh, there's not much under there, and then you start digging and you find all sorts of creatures that you never even knew existed. So yeah, so that was the highlight for me. But yeah, and also I guess forcing us to start looking down and thinking a lot more about what's there. So every time I walk out into the paddock now, I'm got my head down and looking at what's around. So yeah, so we enjoyed it and we've got a lot of value out of doing even those 5 tests. Sort of just gets you thinking about what you're doing out there, and maybe being a little bit more thoughtful about what we start doing.
And I think also to the point made before by Rosie, it took a bit longer, particularly the first one, than we anticipated. So we we were learning as we went. I think got more.
I think next time we'll be pretty quick. Yeah, by the last test, I think it was about an hour. All up for the test. So yeah, it was definitely quicker.
Yeah, great. Yeah, no, look, once you work out how to do it and you've got the equipment, it does become pretty easy to do and smooth, and you get yourself a bit of a system. The second thing I'd say, based on your comment there, Matthew, was that the other benefit of doing some kind of formal monitoring is it actually just helps you practice your observational skills. So even if you don't necessarily want to record everything all the time, just getting out and doing them helps you start to observe and really carefully look at that topsoil as you go. So it gives you an excuse to get out and do, learn, get your eye in, so to speak, with soil. So that's great that you guys, could do that. Fantastic. There was a few other hands up. I think Claudia popped your hand up next, and then Lisa after that. Claudia.
Yes, I just want to say, Rosie, you still beat me. I was a few days late. But I found it good once I felt there was a bit of a hurdle, actually. Oh, I've got to go and do that. It felt like this big thing. And then once you get out there and do it, like you said, Matthew, it was the first one took a while, but then you kind of get into the swing. And I think I've sort of overcome that speed bump of thinking that it's this big thing that's going to take me all day. So I found that good. And yeah, just the observational skills. I think someone had a comment in the chat as well. I found the infiltration test pretty hard because it was so dry in some spots. So I think my results might be a little bit inaccurate with a bit of movement, trying to get the pipe in, but we might be able to discuss that later. But yeah, overall, I think it's been really useful, just getting it started. And now I've got my sights and a bit more motivation to keep going.
Yeah, terrific. Thanks, Claudia. Yeah, we'll come back on that infiltration. And you just get yourself a crate and put all your bits and bobs in it, and then you've got this crate ready to go every time. You just pick up the crate, chuck it on the ute, and out you go. So yeah, you can get yourself organised. So that's great. Lisa, do you want to, what are your thoughts?
Hi. So I'm in Mount Ferry in the Southern Tablelands. I was really excited when this challenge came up. I followed through the soil health card probably 5 years ago with the
I've got my camera turned on.
promising myself that I would do it annually, and I didn't do it at all until this came up. A few little things for me was I didn't mark where I did the survey 5 years ago, so I kind of had to guess. So I kind of was roughly in the same space. So I suppose it's be good to have some ideas on how, whether I take a waypoint or what would be the best way to make sure that I'm you know, testing, comparing apples with apples when I do it next time, I suppose would be a useful bit to talk about today.
Yeah, for sure. And look, having a GPS point or a really clear landmark indicator so that you know definitely where you're taking the sample within, let's say, within a 30-meter square radius is really important because of that landscape variability. So yeah, having a GPS point and staying within 30 meters of that is ideal. And yeah, or if you don't have a GPS, you've just got a really clear landmark sort of system for getting you back to the same place. Definitely really important. Keith, thanks for that. Lisa, Keith, any initial thoughts?
Yeah, good afternoon, everyone. Thanks, David. Just sort of like to echo what other people have been saying. Getting towards the end of the day, doing it wasn't real flash, but trying to fit it in with all our work program. But also, we bought some containers and just shoved stuff in there that Clayton can take back to the kitchen and fit in around his 18-hour days that he was doing getting hay organised. So I think to have a contingency where you can still keep working on that soil profile is probably one little trick that we figured out. And the methodology and the tests weren't really onerous. You just have to get out and do it. And I think, you know, getting those timelines was one of the things that we really need to focus on a bit better. Thank you.
Yeah, no worries. Thanks, Keith. Yeah, I guess there's two things in that. First thing is, yeah, like slot the time each year to do it when it's not in your super busy enterprise time of your enterprise. And obviously this little competition was sort of at this time, so you kind of had to fit in with it. But yeah, have a think about, you know, how it can fit in a bit of a shoulder season if you have one on your place. And the second little tip you had there about bringing the soil back to do things like the pH or aggregate stability and things back in the laundry or the farm shed or wherever you're doing them. When we do like our project work and say we're doing 10 sites across the property, and at each site we're doing 5 different topsoil samples, there's heaps and heaps of soils, and we'll actually, to make it more efficient, we'll take them all back to a shed for a lot of the tests, like infiltration rate, ground cover, those sort of things you have to do at site. But everything else, yeah, if you take your samples out, put them in takeaway containers and label them properly, you just do them all at once back in the shed, and it does save you a hell of a lot of time. Yeah, great. Thanks, Keith. Okay, so there's a few things came in from Facebook, which Sarah, you'll probably be more familiar with me since I don't use Facebook, but I've just got James's kind of summary sheet that he gave us, and so we've got a few people that have sent back in photos, which is great, and results, and just a few questions. So I might just kick it off, I think, Sarah and James, with the first one that came up there. And then after that, just let me know sort of the next ones maybe to cover. And then anyone that's got a live question can come in after that. That makes sense. So the first thing in there really was around infiltration and aggregate stability. So just to really give you guys a bit of a quick summary on infiltration test and aggregate stability test, they're actually 2 different ways to measure soil structure. So when you think about soil structure, it's kind of little lumps of soil, which we call aggregates, little crumbs or lumps of soil, and there's all different sizes of them. And they're called your aggregates, and they're kind of like the solid parts of a soil structure, like the bricks in the wall of a house, for example, each individual brick. It just so happens they're different sizes. And the other part of your soil structure is the gaps between those aggregates, which is your pores. So you've got aggregates and you've got pores, and within each of those, you've got different size and types of aggregates, and you've got different size and types of pores, if that makes sense. So when it comes to water and soils and root growth and soil biology and soils, structure is a really big influencing factor, obviously. And when you do the infiltration test, what you're actually really measuring is what we call the macro porosity, or the ability of the soil to absorb rainfall and for that water to flow into the soil under the influence of gravity. And that initial flow of water in a soil underneath the influence of gravity is the gravitational water, and that is driven by large pores. So generally, the more large pores your soil has, the more aeration it has, and particularly the more it has ability to absorb water in high rainfall, intense rainfall events. Basically, that's a really critical point, that in those storm events where you get a big burst of water, rainfall quickly, a soil with high macro porosity, so which is a well-structured soil generally, will absorb that moisture or infiltrate it very quickly. So that's really what the infiltration test does. So if you do that test when your soil is already saturated, what that means is that your soil pores, the big pores and the medium pores and the little pores, are all already full of water. So a soil will still absorb water at that time, but the flow of water through it will be obviously different because the large pores are already full. So that's what we call hydraulic conductivity, which is a slightly different thing. So you've got a couple of things going on. When you measure that infiltration test when the soil is bone dry or below wilting point or the hygroscopic water, you've still got some moisture in your soil. It's just in the really small pores, and it's not available for plants to get, and even microbes sometimes to get. It's really, really tightly held. And we would just say, oh, the soil's bone dry. It still has a bit of moisture in it, but it's just really tightly held to the surface of the aggregate, of the surface of the soil, physical soil. So if you do the soil test when your soil is bone dry, the infiltration test, you may get a different result. You will get a different result usually than if you do it when you've got some soil moisture. So yes, I think there was a comment there about should we do it when we're coming out of a drought, or at the when we're in a drought, to see what how our soil will cope with that breaking rain if it's a heavy storm, which it often is. And so yes, you can do the test when things are really dry. If you live in a part of Australia that has a seasonal rainfall pattern and you get 3 or 4 months or more of no rain, and you have naturally a dry season, then you could do it right at the end of that dry season, and that will definitely help you. But you could also do it if you're in an area where you have very heavy rainfall, like the wet tropics. Like I've worked with sugarcane farmers that have improved their soil structure, and having more large pores, even when the soil is saturated, gives you better drainage, particularly in the topsoil. You still get better movement of water through because of those large pores, even though it won't be as quick as if it was dry, for example. So the infiltration test does tell you about particularly your macro porosity, or the large pores. And so the other thing, when your soil is dry, let's say you've got a clay soil that cracks, even has a little cracking, or you have like earthworm channels, like those biopores or old root channels, then when a soil is dry and you do the infiltration test, you can get preferential flow of the water going down those large channels and cracks. And so the rest of the soil may not wet up at the same rate. So there's a little bit going on. But from a practical applied management point of view, what we've found, trying to validate the single ring test, filtration test, is if you do a couple of, at your GPS point, if you do, we reckon a minimum of 5, but even if you just do 3 different tests, have 3 rings, do them all at the same time to save you money, and have them all running. It's not too difficult. It just helps you because there is also variability at each site. So if you do it next to a perennial grass or right over a perennial grass, as opposed to a little bit of bare mulch, a mulch area with no perennial grass right there, you may get a very big difference because of the large pores that the root system of the perennial grass has developed, if that makes sense. So there is variability on when and how you do it, and there's benefits for doing it when you're really dry and also when you've got field moisture or when things are fairly wet. Then the second part is the aggregate stability. So I mentioned that your soil structure is really your pore spaces and your aggregates. When we talk about aggregates, we're talking about those little crumbs in your soil of soil, which is pretty much just 2 a.m. at the pub. So it's like all the dead microbes mixing with organic matter and fungal hyphae and bits and bobs of humus and live roots and all the rest of it. They all combine in this little lump, which we're calling, and vomit and spit and ooze and dribble that they've all made, all those things. And all of that mixes with the furniture, i.e. the minerals, and all of that mixed together, and we've got those little aggregates. And so aggregates are really important. They're kind of like the primary structural unit of your soil, just like a brick is the primary structural unit of a brick wall. Those kind of aggregates are primary structural units, if you like, of the building blocks of your soil structure. So if we think about them like that, then when you do an aggregate stability test, you're testing the strength of your bricks, of the wall structure, of the soil structure, and you're testing really the bricks that are going on there. So I'll just try my thing that I had open. No, I didn't have it open. So that test that you guys did, the aggregate stability test, is testing the structural strength of my little bricks. And so ideally, when you carefully place them in a little bit of distilled water, you don't want them to fall apart. So if they stay strong, that's good. So that's what we call the slaking test. So slaking is where that aggregate falls apart into smaller pieces, either completely or partially, over a 10-minute period in the case of this test, because it's just a quick one. So yeah, if it fell apart, so did anyone find that their soils fell apart when they did the aggregate test? Get some thumbs, yes or no. All good. I'll just show you some pictures. I did have something ready to show you guys. So there's a couple of scoring systems that we've used visually. So there are different ways that do it, but basically you can see the top row of photos there is slaking. And so on the left-hand side, that aggregate has completely collapsed. And on the right-hand side, it's staying intact. There's almost no slaking. And so that's an example of slaking. But the second structural change that can happen to an aggregate, apart from it falling into smaller sort of subunits or slaking into tiny sort of pieces, is that the clay that's in your aggregate, if your soil has clay, the clay can get as the soil is put in water, and that water influences the structure and the surface of the pores, etc. And the clay can get removed from the structural matrix and come out into suspension, because clay will stay in suspension in water. And you can see the bottom set of photos there, the left-hand side, where the clay has fairly completely come out from the aggregate and is now in suspension in the water. So that is a highly disruptive soil structure. And that's an example for you of a scoring system for this kind of thing, which is what you guys were following. So this is what we call the aggregate strength, and those two tests. So again, the moisture content of your aggregate does influence your results. So Keith, as you mentioned, you could bring it back to the laundry or the farm shed to finish off the test. It's actually a really good idea to bring your soil back to do this test and leave it, just spread it out a bit in a bit of a tray or a takeaway container and let it air dry a couple of the aggregates before doing the test. So if you leave it for 24 hours and then do it a day later, it is a better way to do that test. Again, it's an extra little task, but it is a time saver. If you're doing, say you've got 3 monitoring sites across your property, which I'm assuming some of you may be thinking of, maybe 2 or 3 sites that you might do because you've got different soil types. You could just bring them back, have them lined up and leave them to dry and then do the aggregate strength the next day. It's actually a really good idea, one, because it just dries the soils out, standardizes it a little bit as well. So that's just something to be mindful of. But that test really tells you the strength of your primary structural units, the bricks in the wall of your soil. And if it falls apart, i.e. slakes, or if it disperses, it's telling you that that soil has soil structure decline, and it could be very problematic from a management point of view. So, for example, if you're doing tillage and it falls apart on you, the likelihood of you pulverizing your soil, compacting it down, sealing the surface crusting is much higher than if it keeps good aggregation when you do the test. So yeah, it is another great little test. It's been around a long time. This is just the quick version of that test. It's called the Emerson Stability Test, the formal name of it. But yeah, it's just a quick and rapid version of it. So a really handy test. So yeah, anyone want to share their results from that test or from the infiltration test? How they went, what they did sort of see from the infiltration test, I guess first. Anyone get over 10,000 mil per hour? So Keith, did you put your hand up there? So just sorry, I'm switching screens there. What was your infiltration rates?
Yeah, I haven't got that just on the photos that Clay sent me at the moment. But for the slaking and dispersibility, it was interesting. He's got a couple of photos there on the site that he's got 0 minutes, 5 minutes, and then he's got another one coming in at 60 minutes. And the lower down in the profile for our samples, the slaking seemed to be a bit better in the topsoil.
Means it slaked less.
But dispersibility was looking quite significant at 60 minutes. It was quite cloudy in the lower structure.
Yes, so there's a couple of things going on there potentially. So the first thing is generally a topsoil, so the 0 to 10 or 0 to 5 or 0 to 15, wherever the high organic matter layer is, generally that level, because of the organic matter and the biological level in that soil, the biomass of all the living things, the greater root volume, all of those things, generally you have, unless there's physical compaction and sealing, generally that layer, because of that organic matter and biological function, tends to have better soil aggregation than the subsoil. So the next layer down, which often doesn't have anywhere near the organic carbon, organic matter levels and biological function. So as soon as you go below the high root zone volume, whichever depth that is, you generally lower your organic matter, which has an influence on soil structure. So the structure in those lower layers is more strongly influenced by your sand, silt, and clay content. So if you've got a clay subsoil, which is common in many areas, not always, but it's common, then, and there's different types of clay, that's another thing to remember. But if you've got a clay subsoil and there's no organic matter, you may get small little lumps or aggregates, which we generally call PEDs when we're talking about kind of aggregates without organic matter. That's a term that's used, PEDs. And so when you pop them into the water and there's no organic matter and spit and ooze and dribble, vomit and the rest of it to hold it together, no organic reinforcement. There's a picky there, thanks for that. So when you do that, then the clay is much more likely to disperse because there's no no soil structure building components of organic matter, microbes, fine roots, fungal hyphae, all of those things are just absent. So if the clay is of a dispersive type, or it can easily go into suspension.
So that's actually one of the pictures Keith might have been referring to
Great.
there for you, David.
Yeah. So I guess,
thanks for that. And if you have a look at the top one and the middle one, it seems like there's little oxygen bubbles coming out of those soil samples.
Yeah.
Which is quite interesting, backing up what you're talking about with the organic matter.
Absolutely. And when you first put an aggregate into water, one of the first things that happen is the macropores get filled, and the micropores and they all get filled with water very quickly in this particular case. And so they will expel oxygen over the next period because there's air spaces that they're filling up. So depending on the diversity of pores and complexity of the aggregation, I guess that expelling of the oxygen will probably go over a longer time period, but that's normal to see that. So one way you can really track improvement in your soil, Keith, is to do your test at say 0 to 5 and then 5 to 10 and then 10 to 15. If you're doing that and you start to see that 5 to 10 or 10 to 15 soils start to stay its aggregate stability to improve over the years, that's telling you that your subsoil is starting to change. So usually that there's more organic matter and root volume in there. So it is a good way to objectively monitor an increase in depth of topsoil, which is often what we're chasing, is to do this test at 0 to 5, 5 to 10, 10 to 15. And yeah, that's a good way to make it a bit more objective, because you can look at it and go, oh yeah, that's deeper, and use a ruler as you dig your cube out. That's also really handy as well. But this is a good way to sort of validate that. So yeah, it's a great test for this. Thanks very much for doing all that. That looks like a fishing tackle little thing. Is it something like that, or you put jewelry?
Yeah, just got it from the hardware, but I thought it was good because you can put multiple tests in it in their own little compartment, and they don't get mixed up.
Absolutely. Yeah. No, they're all good, these kind of things. The second, there is an app as well, everyone, called Slaking, which Sydney Uni developed. So you put the phone, you take a photo with this app over your sample, and then it works out, it scores it for you. But it's a bit dodgy. I think that I was talking to one of the guys that was involved with it. He said the AI there was more artificial than there was intelligence in the kind of algorithm, I think, at this point in time. But hopefully in the future that'll be improved. I'm sure someone can sort it out. Maybe Elon Musk can come in and help us. No, because then we'll have to pay for it. So we'll forget that. All right, Claudia, you had your hand up.
Yeah, thanks, David. I just wanted to discuss quickly with that test. I did one area where we had some remnant scrub that when the place was developed, it was left untouched, and it's softwood scrub. So a lot of bottle trees and currajongs and wilga and things like that. And then it is part of a paddock though, so it gets grazed, but it's original scrub. And then I did just across the fence, so same soil type, but it's all been cleared and all buffle now and gets grazed. And it was just really interesting. The results were the exact opposite of what I expected. So in the remnant scrub, you go in there and the soil smells beautiful and it's mulchy, and there's all that leaf litter is breaking down. So in my mind, the infiltration would have been great and the soil structure would have been better. And yet it almost seemed a bit hydrophobic. The water would just sort of sit on top and not really go through. And then it slaked a lot. It just fell apart. Versus in the pasture, I could actually get the shovel in further. And the soil surface didn't quite seem as good. It wasn't that nice mulchy sort of friable, but I could get the shovel in deeper, and then it didn't fall apart like the remnant scrub did. It didn't seem as hydrophobic. So I don't know. I was very confused by that. It was not what I imagined, but it was interesting.
Yeah, exactly. Look, there's a couple of things going on. So obviously different topsoils form the influence that forms them is different in different vegetation types or ecosystem types. So in some forests where you have a really high litter load, like a classic pine forest sort of thing, you often get fairly high infiltration rates. But yeah, it does depend on, like, because we're saying that it's never been farmed, so it hasn't had the level of disturbance, but it's also has been fundamentally changed in terms of the light dynamics that are going on there. And there are some natural land types where you get kind of a constraining sort of lower A horizon that forms in a forest situation. So you don't get a lot of movement between the very top 0 to 5, for example, and the next layer down. So you get stratification, which is quite typical in forest soils anyway. They have that high litter layer, then they have a humus layer, and then they go to the next horizon down. And in some situations, I haven't got any pictures to show you quickly, but yeah, in some situations that can really inhibit the formation of aggregation below that sort of high humus layer. But then you've got this other factor going on of these water repellent substances in the organic matter, so hydrophobic compounds in that litter, and the breakdown of that litter, the humus fraction that's happening in the soft scrub. So you can definitely get situations where the remnant area is less structurally intact than, say, a pasture. And I'm not surprised that buffel, because for all its weaknesses, buffel is a perennial grass that will build a fairly good fibrous root system. And it's the fibrous root system of grasslands that really does drive structural formation in them. So there's a difference in the way that structure forms in forests to grasslands, and it's all to do with root biomass. So the fibrous roots of grasses and all the exudates they give off tends to give you a fairly well aggregated soil, and it's quite homogeneous, if that makes sense, from say the surface down to 20 centimeters, depending on the condition of the topsoil. But it's a very homogeneous, there's a lot of up and down movement of soil invertebrates like earthworms and other things. They're going up and down as well. So there's a lot of vertical mixing in a healthy soil in a grassland, and the Americans would call that a prairie soil. So the formation of structure can be different. Whereas in forests, when you dig them up, and I've dug quite a lot of forest topsoils up across Australia, they can often, the structure's really dependent on the humus layer. There is some mixing of the mineral from the soil mineral layer up into that humus layer, but it does depend a lot on how well developed that humus layer is. And in a subtropical or savanna type scrub or wet dry tropics, yeah, you don't always get that great infiltration. I have done infiltration tests in central Queensland on grazing landscapes as part of the RASH program when we were doing that a few years ago. And we did sort of in scattered timber, in the canopy zone of scattered timber, and then open areas nearby on the same soil type. And in those cases, the infiltration rate was much higher in the scattered timber. And when we dug a trench, we dug a little trench with a backhoe, just sort of in the canopy zone. So there was grass up to the trees, so it wasn't a competition thing. There was fully grassed under the timber. We dug a trench in that area, and then say 30 meters away where it's open. And there was a lot more large roots of the trees, and so they would have been driving macro porosity big time at that site. But that's different than your little site, which sounds like it doesn't have a grassy understory. If I've got that right, there's no grassy understory in that subscribe. Was there any grassy understory there?
Yeah, there is a bit, actually, not not thick, but there is.
Okay. Yeah, so I think it's just going out and having a look at the soil forming factors, but I'm not surprised that you've got an area, a remnant area, that maybe not as high functioning as what you thought. And you'll see it in other places down south here in southern Australia where the kangaroos have been camping for a long time because of the change in the landscape dynamics. And so it looks like a nice remnant bush, but it may not be as high functioning as maybe what you expect or what it used to be for various reasons. So it's a great point though, Claudia, to not assume anything.
Yeah, thanks.
Yeah, no worries. Any more thoughts around aggregate stability or infiltration?
Hi, David. Can you hear me?
Yeah. Is that Jamie?
Yeah,
Yep.
I had one of my tests I found a bit interesting was a hay paddock with perennial phalaris in it, and during the infiltration test, the first 6 minutes was 340 millimeters per hour calculated, and the second 6 minutes, well, initially it was 0 when I was using 100 millimeter PVC fitting, and then I thought I'll go and get 150, and I redid the test, and that came out at 70. So it was quite a bit less for the second 6 minutes in that particular paddock, whereas all the other paddocks, the second 6 minutes was about half the first 6 minutes. And I just wondered whether you've got any comments about what might be causing that, whether it's a plough pan or something.
Yeah, that is typical when you get a very quick initial infiltration rate, and then if you continue to observe the moisture going in, then it often slows down. One, because the moisture, the macropores in the topsoil are already full, and so you're starting to get closer to saturation, which will change things. But the second thing that definitely may happen is that you've reached a compaction layer in the soil, and so then the infiltration rate will start to decrease at that point for sure. The Northern Rivers Soil Health Card, which I think who mentioned that before? Someone mentioned that when we first kicked off, Rosie, I think. That one has a test where you do the 0 to 10. You do on the surface, and then you dig out a cube and you do the infiltration test at 10 centimeters down as a second test inside a cube, if that makes sense, inside the hole where you had the cube. So you could do that, which again would just give you a feel for how much of a change structurally there is in that second layer.
Yeah.
But it is definitely, it can help you identify, oh yeah, we've got a compaction layer here. But you do have to be mindful that as the soil starts to fill up with water, it does slow the rate anyway. But yeah, it is a good way to sort of, it is a potential suspect is a compaction layer. Thanks, Jamie. Okay, so yeah, Sarah, I'm assuming everyone sort of got a bit of food for thought from that aggregate stability and stuff. There's a few images came in on the Facebook page that James shared with me. Lisa's landscape images and like recent activities and aggregate stability. Thanks very much for sending them through, Lisa, as well. And Matt sent through some pretty serious monitoring going on there. Well done, Matt. Yep, so we can see all them. I reckon you get the chocolates for best laid out monitoring and photos for sure. You guys, do you want to say something, Matthew? Can't show that to everyone. I don't know if Sarah can pull it up. I can't show it.
Yeah, I didn't know where the raise my hand button was. Sorry, a bit slow. I
You're right.
had a bit of a question on compaction versus hydrophobic soils and how that might show up in the infiltration tests and the aggregate stability tests, and how we might be able to sort of pick up where we have compaction, where we have hydrophobic soils from those.
Yeah, generally hydrophobic soils, the top, it's usually the high organic matter top layer. So you'll see it pooling on the surface, and you may see it wet. You may see like a very shallow wetting layer right at the top, and then it just stays bone dry underneath that, really bone dry. But another way you can check for compaction is to scale this little test up. And the way you do that is you get a 20-litre old oil can sort of thing, and you cut the bottom and the top out of it. So you turn a sort of 20-litre oil can into a infiltrometer, and then you get a couple of 20-litre bucket or a couple of 10-litre buckets, and you put water in them, and you add about acrylic white paint at 10%. So just put a bit of white acrylic paint into the buckets of water, about 10% ratio to the water. Mix that up so it's nice and white, and then tip that into the oil can like an infiltrometer test, and then just leave it for a day or two, and then come back and with a spade sort of cut away half of the area that you've done. There's Matt's monitoring there. Then cut away half of where you've wet it, and the white paint will show you where the water's been moving.
Hmm.
So that's a good way to sort of see if you have compaction layers or preferential flows as well. If you've got like large cracks or pores or biopores of dung beetles and stuff, then the white paint trick can help you see that water dynamics really visually. So I'd suggest to you that if you have a compaction layer that you're trying to diagnose how much of a problem it is, or if it is a problem, then that would be a good second step to do if you can't sort of dig a little backhoe trench to kind of really identify it, which is another. If it's a large area and you've got a serious, and you think it's a serious soil constraint, and you may invest in ripping or whatever, then a little trench is a handy way, or a dig stick, which is a soil corer that's designed to go in. You can whack it into about 80 centimeters and still pull it out. That can help you diagnose compaction layers as well. It's called the dig stick. It's about $400, but yeah, you white paint and then just dig it out. But there's, yeah, so hopefully that makes sense, Matt.
So with our results there, you can see we've had about 250 mil an hour for the first one, and then 150 mil, and we were pretty consistent across 3 sites. That was probably in that range. How does that, is that good, bad? Because I was actually quite surprised it was as good as that. Our soils were very dry at the time, so we will go back and do it when it's wet. Yeah, how does that sort of look, I guess, in terms of numbers, and what sort of numbers are we looking for, and does it vary on soil types?
Look, it definitely varies by soil texture. But you will see soils. I've done days where we've had a few infiltration tests, and we've just walked around, say, a homestead, and we've gone out a couple of 100 meters in different directions, and you've got an area that's got fairly dry and another area that might have had irrigation. And in fact, the irrigation area that's wetter has infiltrated faster than the dry area. And it can be partly due to soil texture. Is it a sandy or clay soil difference? But it's also to structure, so to those structural dimensions. So if you're getting up over that 200 to 250 mil, that's getting towards a high functioning landscape for sure. If you're under that 50 mil, so yeah, then it's definitely showing a lower level of functionality. But sort of, yeah, in the initial topsoil, if it's tracking over 200 mil, it's usually a good sign. It could be a lot higher than that. Cracking clays can be much higher than that. You know, you're 400-600 mil an hour or more. It is a derived estimate, obviously, because the soil's wetting as it goes, the test. But but they're the sort of numbers. So if you're 250 in grazing sort of landscapes, then that's a pretty good sign. And if you can creep it up from that, then it's obviously fairly high functioning. I think Sarah and James, there's a Source for Life, have put a little bit of a benchmark in there in the cropping zone. The Soil Conservation Services New South Wales used to benchmark cropping paddocks in the Central West. And yeah, so if you're up over that 150, 200, it's a very high functioning soil in terms of infiltration rate.
Yeah, it was interesting because we haven't had rain for like 7 months out there, and then we've just had some rain recently. And after doing the infiltration, I thought, oh, actually the soil's pretty good. When we get the rain, I won't see too much runoff. But I was quite surprised we were still seeing quite a bit of runoff, and I guess that's why I was sort of asking about the compaction and hydrophobic soils, and maybe it's the mulch that's sitting on the top that's actually affecting that infiltration rates, because we've got quite a heavy mulch over the property because it's been neglected for a while. So
I think the mulch will be helping you more than hindering you. Definitely, you might have some water, some hydrophobic situations going on, and I think as you start to fill your interspaces up with more plants, perennial grasses in particular, you'll find that the infiltration rate will improve pretty remarkably. I'm not sure where you guys are. Whereabouts are you guys?
We're near Esk, so
okay,
so just north of Toowoomba.
No, I know that area. So so generally, like my experience working with the Central Queensland grazing sort of communities around soil health for a few years, the guys that changed their grazing management to a sort of planned approach and improved the 3P grasses and that ground cover, they generally see a very large change in infiltration rate within a couple of years. And that's borne out by the research that has been done in terms of a few different people. David Tongway, who was a rangelands specialist many years ago, and also the grazing land management program, the Queensland DPI did the technical research behind that. And then obviously also say Judy Earle's PhD, she did a PhD a long time ago comparing set stocking and the changes, and one of the things they measured was infiltration rate, and it increased over 10-fold within a couple of years. And anecdotally, me working with quite a lot of graziers, particularly across that Charters Towers to Bowen area, the guys that have changed see a very remarkable change in infiltration of water, and they don't get as many gully busters and things down their creeks. And it's only a couple of years before they see that significant functional change.
That's good.
Yeah,
ground cover was very low, so yeah.
Yeah, that's the other thing that's sort of going to influence this is, you know, where you take your sample. If you've got 60% or 50% ground cover, and you do all of your rings between the grasses in the bare area, that's different than if you do your rings right on top of a perennial plant. So you probably find the infiltration rates quite a bit higher when you do the ring right on top of a perennial grass, for example.
Yeah. But on the positive, we were pretty surprised. We expected our aggregate stability to be worse, so we were pleasantly surprised by that result. Mate,
every time you get a bonus, then take it, because so means you haven't got that. Because if it was all slaking or dispersing on you in the topsoil, then and you've got bare ground, then those two things combined will often lead to surface sealing and crusts forming, and that makes it even more problematic. So having that ground cover on there is a critical first step, that mulch and stuff. The second step is to start getting more perennial plants per square meter, and the legumes and the forbs as well, but getting more plants per square meter, that would significantly change things for you quite quickly.
Awesome, thank you.
And that leads to the thought process, doesn't it, David, where I know after a rain event, often people get excited about dams filling and things like that, whereas those that have changed their management, this sort of dams aren't filling yet, but it's actually something to understand, a different observation to make, that it's actually great that you mightn't have it getting into the dam as quickly, because you're actually filling up the landscape first. So
exactly,
which is what we want to see. So it's even those sorts of observations that you find. And then if you've got if you think about your landscape and look for your sponge areas, or your areas where water naturally, when the landscape hydrology is functioning, that water naturally absorbs, like little alluvial systems, little floodplains, swampy meadow type areas, those areas where water naturally in a healthy system slow down and absorb, then you start to think, well, they're going to be chock full, and they're, depending on where you are in your landscape, they're often a much larger water storage than your dams, your surface dams. And so then you might just start to have them as your water source rather than all these dams, which are boom bust sort of things anyway. So it's about changing the whole dynamic, I guess, over time. Thanks, guys. That was, pretty impressive. I can see everyone's pretty impressed with your paperwork. I think Claudia wants you to go and help her actually do all her paperwork for her by the look of it. Sounds good. Any other? Greg's got his hand up, and maybe if you want me to find your data as well, Greg, would that be helpful?
Greg and then Christine. Righto, Greg, jump
in. No, I didn't want you to find my data, but I was just interested to ask David what he thinks about soil penetrometer measurements, and our land care group had one of those, and I did quite a bit on my place because it's a lot of the paddocks had been used for cropping way back, for growing maize and so on, and it did tell me a good deal about where I had hard pans, where I had hard layers, but I'd be interested to know whether or not you think it's of any practical value to somebody like Matthew, who's talking about trying to see the difference between soil compaction and hydrophobic soils.
Great point, Craig. I did forget about the penetrometer. Look, they are a useful tool, a bit like the infiltration test. They are very moisture dependent. So obviously when your soil's completely saturated and you use a penetrometer, it just slides straight in. So you have to use them when you've got field moisture or just below, because when you try and use them when things are bone dry and soil strength so high, they don't work then. So they're a good tool when you've got field moisture or just below field moisture. And I think you've hit the nail on the head from my point of view. They're a good way to diagnose compaction layers. I prefer, for me, that's their most useful thing they help with. But you do need to use them when you've got reasonable soil moisture, because otherwise they can be a little bit misleading, like when your soil's really bone dry, the soil strength's so high. But again, if I've got really good soil structure, then they are going to show you that even in the driest end of the scale, if that makes drier end of the soil moisture scale. So yeah, definitely another tool in the toolbox for sure. I'm not a big fan of them in my work, mainly because I've broken every single one that I've ever bought pretty quickly. Like the meter, the end scale thing on them just gets smashed somehow. So I just find that they are a bit relative. So I find the infiltration tests, I find it a bit easier for me, but it does. And I find the dig stick is really helpful to looking at compaction layers, because you can whack the dig stick in even in dry soils, and it will tell you, it'll give you a pretty good visual assessment of bulk density through the 0 to 80 or 0 to 70 that you can kind of whack it in depending how dry it is. But yeah, definitely it's a tool, and it's a pretty useful one. I know a lot of probably croppers use it more than pasture grazing people, and I think it definitely has a place. Yeah, thanks, Greg. Christine, you wanted to throw something in?
No, I was just doing a hand clap reaction to Matt
Okay,
at
no
the
worries.
wonderful presentation of his results. It was it certainly leaves my results. It gives me something to aspire to something to
Yeah, great.
aim
Yep.
towards. So no, thanks, Matt. But no, it's good seeing everyone's results online and just comparing where mine fits in. I've got a fairly dry loamy soil, and due to years and years of various livestock use, it's fairly devoid of living material. So that's this whole process has given me something to concentrate on and to actually measure it. So thanks.
Yeah, great. Yeah, no worries. No, that's great. Thanks, Christine. The thing about monitoring your soil like this, there's different indicators, obviously, that you guys have been looking at, different aspects of your soil, is that it helps you troubleshoot as well. Like, it's easy to just say, oh, I'm just going to buy that product because it'll solve all my problems, or this, or do this. But it actually helps you diagnose a bit more what we call your soil constraints are, actually. It doesn't give you the solution, but it helps you target the problem, and you go, okay, well, the problem is actually structure more than pH at the moment, or whatever it might be. But it helps you with your soil diagnosis, particularly your soil health or soil system functioning, if that makes sense, not necessarily nutrient levels, which is a kind of separate management job. Yeah, good on you, Chris. Yes, so he's been seeing how everyone else has been up to, and then he can tailor what he's doing. Yeah, exactly. And look, there are different ways to measure lots of different aspects of soil. So soil structure, and you can also use bulk density, which is not too difficult to do with a bulk density ring. That's another way to sort of see whether I'm getting more air porosity in my soil. So there are different ways you can do it, and it's about choosing a few techniques that work for you and that are easy to use and relevant for your soil. And then you can calibrate them over time. And I think, Claudia, your idea about going to different land use patches and getting yourself a bit of a, like, what do you want to call it, a baseline across different land use patches, because I reckon even if you go to different patches of softwood scrub, you'll find that they're in different condition, just depending on the specific sort of dynamics of each patch. So yeah, the more you do it, the more you get an understanding of that dynamics across your topsoils. So I reckon, because you'll often dig up a forest soil next to a pasture soil, you know, like 10 meters away at the same time, and the pasture soil will have moisture and the forest soil won't. It'll be quite dry. So, you know, you're going, hang on a minute, these are 10 minutes apart. So there's differences in the dynamics of the moisture, the water cycle as well, that's going on in that system. Yeah, cool. Okay, just trying to look at that form. I think we only got a few minutes left, but to know what else jumped
so we've
out
only
from
got 10
Facebook,
minutes.
Sarah. Yeah.
Yeah.
Anything else
Yeah.
jumped out from diversity? You maybe chat a bit about soil organism, invertebrate diversity. Did anyone see any organisms? I think you guys, Matt, you said you guys saw something, but yeah, what was the moisture environment? What's been the rainfall, you know, the last few months? These things influence it. So what kind of things did you see?
Yeah, well, we were expecting not to see anything because it had been so dry. But when we started digging, I mean, we already knew we had a lot of spiders because they're just everywhere. But then actually to see that we found a worm, which I wasn't expecting. The surprising one was this little cicada. We didn't know what it was. We had to ask a friend, the cicada larvae. The fact that they live underground for 6 to 8 years, and then they only live above ground for 6 months. I think they should spend more time underground. Yeah, it was quite fascinating. And there's a lot of things that I found that, like, really small things, you know, my eyes aren't that great to be able to see what they were, and lots of little larvae grub things. So obviously things that we see above ground, but probably, and so that, I guess, for me was eye-opening of there's actually bugs that spend more time below ground than above ground, and we only see them when they're above. And we've also noticed in the last probably couple of weeks a lot of holes appearing in the ground. So that's making me a little bit more curious as to whether they are the cicadas or whether we've got a lot more of like the Christmas beetles or those sorts of things coming out. So that was what I found quite interesting. I tried not to take any tests on ant nests because we've got plenty of those as well.
No worries. No, plenty of bioturbation going on, we call it. Yeah, and the ones that are harder to see and that are usually more moisture dependent in terms of when you see them are the medium to smallish medium guys. So for example, the springtails and mites, because they will often be a quarter of the size of a pinhead, if that, to give it sort of relative size. And you do have to sort of train your eye on that tray to see them. But once you do, you start to see them, especially if you've got a bit of a magnifying glass, you can start to see those guys. Another way you can see what type of beetle larvae or whatever is making those holes is you actually make a box up. It can be a cardboard box, but a timber box is a bit more sturdy. It might be, you know, like 60 centimeters by 60 centimeters, like a proper box without any bottom, and you just put that onto the surface of the ground so that it's completely dark, and then you just have a hole, like a drill, like a, I don't know, 10 centimeter diameter drill hole. You drill a hole in one side of the box, and you can put a bottle, like a catch plastic bottle, on that, or a bag, and then as those insects go from their larva to their adult stage, they come out of the ground and look for light because they're becoming a flying beetle or whatever. They will go out of that hole and then end up in your bottle. So that way you can kind of see what's coming out of the ground when it's turning into an adult stage of its life cycle. So that's one way you can capture those guys. There is a technical name for it, and I have got it in one of my library books I'm looking at over here. But yeah, it's pretty simple. It's just a little, literally a box that you put on the ground that's obviously solid, so there's no light. But then you just have one little exit from that box, and just get some kind of plastic bag, or particularly like a big bottle that can just catch everything that's coming out. And that way you can sort of see what kind of creatures are coming out of those holes. The other way is just to put mustard. So you can get mustard powder, you know, or curry, that people like cut curry powder, like sort of mustard powder. If you make up a solution of that with water and tip it over the soil and let it drain in, earthworms don't like mustard. They really hate it. So they'll all come to the surface as well. So you just do the old mustard. But if they're endangered species, you're technically breaking the law by doing that. But you will see them come out, and then you'll be able to see, oh yeah, good, a few earthworms coming to the surface here. So you have to use Keen's mustard, the good old fashioned one, not these modern ones that are full of bulkers and fillers like rice powder and all this crap they put in them. Use the real deal.
I was going to ask if you have rice with that.
You could, but if you just mix up your mustard powder and in a bit of water and tip it down a couple of into the soil, see if you draw any earthworms up. Obviously, if it's pretty dry, they're going to be pretty sleepy anyway. But yeah, in your moist season. Kind of like the Japanese way of counting whales. It's a bit destructive sampling. The better way to do it is just dig up your cube and spread it out on a bit of plastic and count them and put them back in the ground. But if you do want to do the destructive sampling method, that's another way to do it. So that's good. Yeah, obviously moisture definitely influences the soil invertebrate diversity count. And so doing it at that time of year when you have moisture is good. I think Shane, there was a question Shane had that came through via Facebook that you could do your soil invertebrates when it's a bit dry. That's a fair point, Shane. If you do see something when everyone else is not seeing anything and you're seeing some things, it tells you that your moisture status is higher. There's no doubt about that. And probably your temperature is a bit better in that topsoil, because a lot of them in the very extreme temperatures, if your soil's really cooking and baking in the summer, then obviously a lot of them will be dormant. They'll go south. So yeah, it would tell you that your soil's functioning pretty well. There's definitely advantages for doing some of your sampling or monitoring in the dry. There's no harm in it. But for a lot of the living things, it's better to do it when you've got a bit of moisture around and a bit of plant growth.
So was there any other questions like on areas that we didn't cover as much, like your ground cover observations or anything like that before we wrap up? Everyone's pretty comfortable.
Yep.
Needs more rain is probably what most of you are wanting to say. Yeah.
Great. Oh, well, thank you so much, everyone, for making the effort on a Sunday and, making the effort to take part in it. I think it's a great little initiative, and I think it's the start of something that'll just grow and grow. But I guess the main thing is just as systematically, whether it's once a year or once every 6 months, go out to your site and take some objective observations. It's really the way that you'll be able to reinforce for yourself that what you're doing is making a positive change to your natural capital, in this case your soil.
Yeah, and I guess to close with thank you very much, David, for your time with us, and likewise on a Sunday. Great to keep our minds invigorating. And I guess, if there's any more questions that you have that come out of today's conversations, and then even from whatever observations that you make, please, keep asking them in the Facebook group, and even funny little things that you see and you wonder what it is, pop it in there and share with us all. And, we all learn together, a bit like some of those, organisms that you found, Matt, that you weren't sure about, that you found a friend. Maybe even, some of us might have learnt from that as well. And I guess, there's still time for those that maybe haven't done as many sites as they thought they might do. And for those that might have been lucky and got a few mils of rain the other day, to maybe grab another site and see the difference. Because I guess this is very much about being in practice, giving it a go, learning that more often you do it, the easier it gets, but also that sort of the calibration, I call it, of your eye and your mind about these observations that you're making, and literally getting you into the paddock more often is just so more, so important. And then, thinking about how you're storing these and making sure that you can get back to this data, to make sure you can have that opportunity to be able to reflect when moving down the track, when we do things again in autumn, in March, to compare, would be fantastic. And I guess, yes, we're all hats off to a few, all these great different ways people use things maybe that were in the cupboard or in the shed. That it's been fun, even just observing the different things that people grabbed to utilise whether it was for the ground cover observation or for their aggregate stability tests and things like that. It was great, actually, even to see, you know, the outside thinking that went there. So yeah, and yes, please keep communicating, and thank you again all for your time today. Really appreciate it.